All right, so it's already 3:34. So again, before we'll start our discussion for today, do you guys have any question or clarification regarding with our topics last meeting?
None, sir.
All right. Okay, so can you guys see my screen now?
No.
Yes, sir.
Yes, sir.
All right.
Yes, sir.
Okay, so for our topic for today is relation. All right. So what is this relation? So as you guys may already know, this one is a set of two elements. Okay. So it could be a set of this set of this set, and this set, and so on and so forth. Okay. So you cannot form a relation if you don't have two sets. So if you only have one set, or let's say one element, okay, to be specific, you won't be able to form a relation from that case. You need at least two or more. Okay, so in here we have two sets. So we have the x and y. Okay, so imagine that having a Cartesian product can give you all the kinds of relations. So what I mean by those relations, that one is actually in the form of ordered pair. And before you could say that that one is already in an ordered pair, there's actually this so-called rules or conditions that need to meet before we could see that they are already an ordered pair. Okay, but for now, to make it simple, when we say Cartesian product, it's just simply the multiplication from this set to the to another set. Okay, or x times y. So in symbol, you could write that one in like this: x times y, or coordinate x times coordinate y, or in other words, we call this one domain multiplied to our range. Okay, so sometimes this range is also called codomain. Okay, so we have the domain and then codomain. Okay, and then just take note on this one. The first ordered pair, this one, is having an element x, and then the second ordered pair is having an element y. So their arrangement is very important. Okay, so as you can see, we have here the x first before the y. So as you can see right here, we have here the first, we have here the x also before the y. So we cannot say y and then x. Okay, so that's a different set of ordered pair. Okay, as you can see, x is the element of the set x, and then y is the element of set y. All right. So again, the first element x of the ordered pair is related to the second element y of the ordered pair is called binary relation. Okay. So you can also have the vice versa. You can have the y first, and then followed by the x. That is also called binary relation. But that one depends on the arrangement that is mentioned or put in there. Okay. All right. So let's have an example. What is this binary relation? So as you can see right here, we have the student and then the course. So we have two sets, a set of student and then a set of courses. Okay. So as you can see, Bill is related to comp sci. Mary is related to math. Bill is related to art. Beth is related to history. Beth is related to comp sci. And then Dave is related to math. So all of them has a relation on each set. Okay. So Bill is related to comp sci. So this Bill is the element x, and then this comp sci is the element y. And then this R here means in relation or related to. Okay. So you can read that with those two denotion. Okay. So x, r, y. Okay. So we have 2, 4, 6 elements, and 6 elements also on the other side. So you can list this one by having this kind of set wherein we have this R, meaning this Bill is in relation with comp sci, this Mary is in relation with math, this Bill is in relation with art, and so on and so forth. So this one came from our table. Okay, and as you can see, so this one is also is already an element of this relation. So we could say, so it's like the opposite, bet history is an element of R. Okay, so therefore we can write that bet R history, or bet is related to history, or bet is in relation to history. So all of those, meaning maybe this is the course of Bill, this is also the course of Mary, this is also the course of Bill, wherein Bill has two courses taking at the same time. Same with Beth, is taking history and comms at the same time, and then Dave is also taking math. All right. So yeah, simple as that. Forming a relation between two sets. So did you guys understand it so far when it comes to forming a relation?
Yes, sir.
All
Yes,
right.
sir.
Okay. So we have here a super easy Seatwork. Okay. So just write the relation as a set of ordered pairs. So we have 1, 2, 3, 4, wherein it's in a table form, and then it's asking you to have an answer which is similar to this one. Okay, and then we have the number 5 wherein it's the opposite. So it's already in a set format wherein you need to uh, write that one into a table. Okay, just like this. All right. So are we clear so far with this secret number 1?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Great.
Yes po.
Very good. Okay, so let's now talk about graph. Okay, so this one is also super simple. Now, going back to the Cartesian product. So as you guys may all know, we have two coordinates. We have the x coordinate and then the y coordinate. So the y coordinate again is the range or the codomain, and then the x coordinate is your domain. Okay, so as you can see right here, whatever is the first coordinate, that is always your domain. Okay, or your x coordinate or x horizontal line. Then whatever is the second coordinate, that is always the uh, range, okay, or codomain, wherein we have here y is equal to a, b, c, d, and then x is 1, 2, 3. Okay, so just label it here. So 1, 2, 3 for the domain, and then a, b, c, d for the range. And then we have here the sample relations, where it is saying that we have a relation of 1a, we have a relation of 1b, 2a, 2b, and then 2c. So just simply plot them on our graph. So 1a, 1b, 2a, 2b, 2c. Okay. So all of those plots are actually a relation, okay, or a plot of relations. Okay. So let's talk about the domain and then the range. So as I have said a while ago, whatever is the first one, that is always your domain, and then whatever is the second one, that is always your range. So we have here the domain, which is ABC, and then the range is 1, 2, 3, 4. And then they have their own relations with each other on both sets. So we have A3, B3, D1, and B3 and C5. All right. So are we clear so far regarding with domain and range? Hello, guys. Can you
Yes,
guys
sir.
follow? Okay, so let me just
po.
repeat.
Sir.
Okay, so your domain is your first coordinate, and then your range is your second coordinate. All right, so let's have another example. So we have here the table, which is also the same like what we have on the past slide. So in here we have the domain, Bill, Mary, Bill, Beth, Beth, Dave. And if you're going to list that one on a set, so we're going only to have 4 elements instead of 6. Why is that? Because this one is already in a form of set. And as you guys may all know, if it's in a set, it should be distinct and unique elements only. So there should be no repeated elements. Okay, so we have 2 bills, so just eliminate the other one. We have 2 bets, just eliminate the other one. Okay, so having a total of 4 only. So the same with the range or the y coordinates. So we have 2 mats, we have 2 size. You can just remove those 2. Okay, having 4 uh, elements also on your range. Right? So this one is super easy. And we have another example here, which is having an element x, I mean set x having an element of 2, 3, 4, and then element y having an element of 3, 4, 5, 6, 7. So it says here, define a relation R from x to y by xy. So take note, this is your first coordinate or your first element, which will be coming from your set x. Then y is the second one, which will be coming from your second coordinate or your range. So here's the condition. So xy is an element of relation if x divides y, having a zero remainder. So as I mentioned on the second slide, I said that relation is forming a relation. Okay, so let's say in real world we have a relation of being friends, relation of becoming an enemy, becoming a colleagues, becoming a co-worker, etc., etc. So there's a lot of relations. Okay, but in here, in relation or in mathematics, we have rules or condition wherein we need to meet that one before we could say that they are in relation with each other. Wherein x and y will be only related with each other if this one were met. Okay, wherein x divides y is equal to even or having a zero remainder. So my question here is, what is this x divides y? Is that x divided by y or y divided by x? Anyone who can answer this one? Is this x divided by y or y divided by x?
Y divided by X, sir.
How about the others? Do you guys agree with Mr. Lapsan? No, hindi yata sila agree sa'yo ah. So the rest are x divided by y.
Divided by X, sir.
Y divided by x also. Okay. All right, so I'm assuming that those who didn't answer, so maybe your answer is x divided by y. So the correct answer is y divided by x, okay? So be wary on this one, x divides y, meaning x is your divisor that will divide the y, okay? So let me just copy this one so that we can answer this one by one. All right, so we have here a condition wherein, of course, the x first followed by the y. And then we have here the another condition wherein y divided by x must be equal to even, or you must not have a remainder or having a zero remainder. Okay, so this one is the same with this one, because if your answer here is even, then you don't have a remainder. But if your answer here is let's say odd, maybe you have a remainder. Maybe it's no. This one is wrong. You can have an answer of odd, but that one or they are still in relation. So let's remove this one. Having a zero remainder. All right, so there you go. Okay, so first one here is 2, 3. Okay, so just follow this one wherein 2 is your x and then y is 3. So of course, 3 first because this is the format of your formula. 3 divided by 2. Okay, will you have a remainder on this one?
Yes, sir.
Okay, so this
Yes,
one
sir.
is no. Okay, how about 2, 4? Wherein that's of course 4, 2. Are we going to have a remainder here or no?
No,
No, sir.
sir.
Oh, so this one is 2. Okay, so 0 remainder. So this one is correct. How about 2, 5? So is this or are they in relation? So take note, our condition here is having a 0 remainder. If we don't have a remainder, then meaning they are in relation. But if we have one remainder, okay, then they are not in relation anymore. So is this 2, 5 in relation with each other?
No,
No,
sir.
sir.
No,
So
sir.
one will give you a remainder. Okay, so just do that 1, 2, 3, 2, 4, 2, 5, 2, 6, 2, 2, 7. Okay, so what are the other numbers that will not give you a remainder? Okay, or what are the ordered pairs that will make a relation with each other? So first one here is 2, 4, of course. What else? How about 2, 6?
Yes, sir.
2, 7.
No, sir.
2, 7 is a no. Okay. How about 3, 3?
Yes,
Sir.
sir.
All right. How about 3, 4?
No, sir.
3, 5?
No, sir.
3, 6?
Yes, sir.
3,
Yes,
7?
sir.
3,
No, sir.
7? No. Okay.
No.
4, 3?
No, sir.
4, 4?
Yes,
Yes,
sir.
sir. Yes, sir.
All right. How about 4, 5?
No, sir. No,
4,
sir.
6? 4,
No,
6?
sir.
4, 7?
No, sir.
No also. So as you can see, we have only formed 1, 2, 3, 4, 5 ordered pairs from this condition. Okay. So this is now our answer. Okay. So 2 and 4 is in relation with each other. 2 and 6 is in relation with each other. 3, 3, 3, 6, and then 4, 4 are also in relation with each other. All right. So did you guys get it so far?
Yes, sir.
Yes, sir.
Yes, sir.
So if we have this condition wherein, let's say, the first element here is y and then followed by x. Okay, so just interchange those two. So this one is very important. So this is the first thing that you need to check. What is the arrangement that you will list on the set relations? So in here, x first followed by y. So that's why we put here the x first followed by y. But if we have yx, then just do the opposite. Okay, so just list here 4, 2, 6, 2, 3, 3, and then 6, 3, and then lastly, oops, is 4, 4. All right, because those two are two different. Okay, so this is the first condition and then second condition. Right, so are we clear so far?
Yes, sir.
All
Yes,
right,
po.
very good. So now let's move on to the example number 3. So let x is equal to 1, 2, 3, 4, and then a relation R defined by xy is an element of the relation if x is less than or equal to y. And then we have another condition here, and x and y is actually an element of x. Okay, so your x can be found on your set x. Your y element can also be found on your set x. Okay, so you might be wondering where is that y elements. Okay, so in here we can find the x and y elements on set x. All right, so let's answer this one. So what are the least of possible ordered pairs which are in relation with each other? So we have here this condition. So again, we have the xy. So x first followed by the y. We're in no problem since we only have one set, which is 1, 2, 3, 4. And then we have another condition here, which is x should be less than or equal to y. Okay. So yeah, this one is super easy. So you can use the Cartesian product in here, wherein you can multiply it on itself and then get all the possible ordered pairs and then compare it with the use of this condition. So for now, we will list all of the ordered pairs. So we have the 1, 1, we have 1, 2, 1, 3, and then 1, 4. So of course, we also have 2, 2, we also have 2, 1, 2, 3, and then 2, 4. We also have 3, 3, 3, 1, oops, 3, 1, and then 3, 2. So sorry for my ugly drawing since it's very hard to draw using mouse. And then 3, 4. 3, 1, 3, 2, 3, 3, 3, 4, 2, 1, 2, 2, 2, 3, 2, 4. And then lastly, we have here the 4, 4, 4, 1, 4, 2, and then 4, 3. Right, comma, comma, comma. Okay, so here are all the possible ordered pairs when it comes to this set or elements 1, 2, 3, 4. Okay, so our condition here is x is less than or equal to y. So from there, we could list now all the possible relations. So is 1, 1 in relation with each other? 1, 1.
Yes, sir.
Yes. How about 1, 2?
Yes, sir.
Yes, sir.
Yes. 1, 3?
Yes, sir.
1, 4?
Yes, sir.
2, 2?
Yes, sir.
2, 1?
Yes, sir.
No,
Huh?
sir.
No, sir.
No, sir, no.
So this one
Sir.
is no. 2, 3?
No,
Yes,
sir.
sir.
Mas maganda pag mas mabilis kayong sumagot. Mas mabilis na matatapos. Okay? So, dalian natin, okay? So, 2, 4.
Yes, sir.
Yes, sir.
So, you
Yes,
guys
sir.
can just leave your mic open so you don't need to, tap the space bar from time to time. 3, 3.
Yes, sir.
No, sir.
1,
No, sir.
No,
No,
sir.
3, 2,
Oh,
No,
No,
sir.
sir.
3, 4,
yes.
Yes, sir.
4, 4,
Yes, sir.
Yes,
No,
Yes,
sir.
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 4, Y,
No, sir.
No, sir.
No, sir.
4, 2,
No, sir.
No,
No,
sir.
sir.
No, sir.
4, 3.
No, sir.
No,
No,
sir.
Alright, very good. So, from there, just list all of the validated, okay, relationship wherein we have the 1, 1, 1, 2, and so on and so forth. So, from there, we have 1, 1, 1, 1, 1, 2, 1, 3. So it's quite long, okay? So just list all of those. So 1, 1, 1, 2, 1, 3, 1, 4, 2, 2, 2, 3, 2, 4, etc., etc. Okay, so the one that has an X is not a valid relation from this question. Okay, so as simple as that. So did you guys get it?
Yes, sir.
Yes,
Yes,
sir.
sir.
All right, so when it comes to forming a relation, so we only have two uh, things that you need to worry about. So we have here the arrangement of your ordered pair. So we have the x, y, or yx, so it depends. And then we have the condition, wherein in here, x is less than or equal to y. All right, so simple as that. Let's now move on to example number 3. So from here, we have listed all of the possible or all of the validated relations. Okay, so this one is actually this one. And then here are the answers. So when it comes to digraph, okay, so we will represent those relations using a digraph. So from here, this one is actually super easy. So you can see this 1, 1, 1. So 1, oops, 1 going to 1. And then 1, 2. So 1 going to 2. 1, 3. 1 going to 3. 1 going to 4. And then we have here 2, 2. So going back to itself, we have here 2, 3. We have here 2, 4. 3, 3. 3, 4. And then 4, 4. Okay. So this is a representation of a digraph, okay, from a relation set into a diagram. Okay. So did you guys get it so far? So this one is super easy.
Yes, sir.
Okay. So the first one here is the ordered pair, and then the next one that has an arrow is the second coordinate. Okay, sorry, not ordered pair. The first coordinate here is not having an arrow, and then the arrow that is going to the second element is the second coordinate. Okay, which is 1 and then 3. All right. So that's the representation of number 3 into a diagram. Okay, so let's now proceed to example number 4. So draw the relation R on X is equal to A, B, C, D, defined by R is equal to AA, BC, CB, DD. Right? So this one is also super simple. So as you can see right here, we have 4 elements. All you do is list those first. We have the A, B, C, and then D. Okay, so we have here the AA. So A going back to itself. And then we have here the BC. So B going to C. And then we have here the CB. So C going to B. And then lastly, we have here DD. All right. So did you guys get this one so far? Example number 4.
Yes, sir.
Yes, sir.
How about the others? I'm only seeing Mr. Labsan,
Yes, sir.
Sin.
Yes, sir.
Yes, sir.
Yes, sir.
All right.
Sir.
All right. So very good. So again, if there is a part that you didn't understand, so let me know that part as soon as possible. All right. So once you're done with those examples, once you have fully understand those examples, then you may now proceed and answer this Seatwork number 2. So we have here the letter A wherein you need to draw the diagram of the relation. So we have 2 relations. And then letter B here is to write the relation as a set of ordered pairs. So instead of diagram, so it's the opposite. So it's asking you the set of ordered pairs. Okay. And then for letter C, we have here the relation R on the set 1, 2, 3, 4, 5 defined by the rule X, Y is an element of R, wherein we have this first condition, second condition, and then third condition. So each one of those needs to be answered. So basically, you're just going to list all of the ordered pair or set ordered pair. Okay, we have A, B, and C. And then take note, after getting all of their ordered pairs, you need to answer this one, 1, 2, and 3. So 1, 2, and 3 for letter A, 1, 2, and 3 for letter B, 1, 2, and 3 for letter C. So number 1 is elements of R. So very simple. 2 is the domain of R, and then 3 is the range of R. Okay, so just beware in this one. So you need to answer this one also in each of those letters. All right. So are we clear so far regarding with the Seatwork number 2?
Yes, sir.
Yes, po.
All right. So so you can answer this one using a Microsoft Word, or you can do this one handwritten. Okay. So I am now giving the option to you guys to choose what is your preferred way of doing our activities. So if you can do it on Microsoft Word, better. But if you're going to do it handwritten, please write legibly, okay, so that I can read it properly. Okay. All right. So let's now move on to the next one. We have here the properties of relations. So in total, we have 4 properties. So we have here the reflexive, symmetric, transitive, and then anti-symmetric. So reflexive first, meaning when we see reflexive, if we have, let's say, an element 1, 2, and 3, so each of those elements should reflect itself. Okay, that's why it's called reflexive. So what do I mean by reflects itself? Meaning it should have an ordered pair, let's say 1, 1, 2, 2, and then 3, 3. Okay, so if one of those is missing, let's say we have 1, 1, we have 2, 2, but we don't have 3, 3, then that set is not a reflexive relation anymore. Okay, so it should be all of your elements. Then the second one here is symmetric. This one is also super simple. If we have, let's say, variable xy or element xy, of course, they are 2 different elements, let's say 1, 2, excuse me, then we should also have 2, 1. Okay, so basically it's just the opposite. Your domain will go to your range and your range will go to your domain. Okay, so just do the opposite. So if you have 1, 2, you have 2, 1. If you have 4, 2, you should have 2, 4. If you have 5, 5, well, still the same, still 5, 5. If we have 1, 10, you should have 10, 1. Okay, that's symmetric. Okay, so they are symmetrically the same, vice versa. All right, we also have here the transitive, wherein we have x, y, and then we have y, z. So if we have this condition, x, y, so this one is actually a total of 3 elements. So we have x, one element, we have y, another element, so y, y, and then z, another element. So we have a total of 3 elements. So if you see this condition wherein this ordered pair is having the range the same with the domain on the second ordered pair, then it must have another ordered pair forming an xz. Okay, so for now it might be a little bit confusing, but it's quite similar, or actually it's super similar with the hypothetical syllogism. So this one is in inferencing rule, then this one now is in relation. So we have P conditional Q and then Q conditional R. So this one is actually can be answered as P conditional R. So as you can see, we have eliminated the Q in here. So in here, we will not eliminate the Y, okay, but instead we'll create another element or ordered pair having, let's say, XZ or PR, okay? So anyway, so we'll be having an example with this one so that you guys can understand this one a bit more. And then we have here the last one, anti-symmetric. So this one is super simple. If it's not symmetric, then that one is anti-symmetric. All right. So if we have, let's say, x, y, but we don't have yx, then that one is already anti-symmetric. But if we have x, y, and we also have yx, then that one is symmetric. Simple step. So did you guys get this one at least 50%?
Yes, sir.
All right, so I hope the others didn't answer. Also understand this one, at least 50%. So I'm not asking your full understanding since we don't have an example yet. All right, so let's move on to the next one, of course, focusing on the reflexive relation. So as you can see right here, if we have xx for or r for every x is an element of x, we have example number 1, x is 1, 2, 3, 4, and a relation r defined by x, y is an element of r if x is less than or equal to y and x, y is an element of x. Okay, so this one is actually the same with the example before, wherein we have answered the, no, it's not here anymore. So we have here x less than or equal to y. So we have listed all of the possible ordered pairs before and then validate them if they are really in relation with each other. But in here, we have already the listed validated in relation regarding with this condition. So the next thing that we need to validate is whether this one is reflexive or no. Okay. So the only thing that we need to check in here is the list of elements, of course. So we have here 1, 2, 3, 4. And then from there, you have to check if this one has an ordered pair 1, 1, 2, 2, 3, 3, and then 4, 4. Simple as that. So if you can find those ordered pair on this relation, then this relation is reflexive. And as you can see, this one is a reflexive relation since we have 1, 1, we have 2, 2, we have 3, 3, and then 4, 4. And then again, if we don't have one of those ordered pair, let's say we don't have 3, 3, but we have 1, 1, 2, 2, and then 4, 4, this one is not a reflexive relation anymore. All right. So all of these elements should have an ordered pair that reflect to itself. All right. So are we clear on that?
Yes, sir.
All
Yes,
right.
sir.
So this one is quite simple. Anyway, so we don't have enough time anymore, so we will just continue the rest on the part 2. All right. So right now we are 17, so I'm 16 rather. I'm also expecting to have 16 participants on the part 2. All right. So goodbye and see you guys on part